Hi guys, today let us study about the numericals based on the concept of friction in a wedge. Well, what is a wedge? A wedge is a piece of wood or metal which is usually triangular or trapezoidal in cross section and is used for lifting heavy loads or used for making slight adjustments in the position of the bodies. Hence, as you can see in the figure, this is a wedge. Well, a block weighing 10 kN is to be raised by means of 20-degree wedge as shown. Find the horizontal force which will just raise the block if coefficient of friction for all the surfaces is 0.3. Now here they have given in the figure a wedge which has a 20-degree angle and a body which is placed upon the wedge. Hence from the figure you can see that as there is a horizontal force applied on the wedge, the body will start to move along the inclination of the wedge and hence will slightly move upwards. Hence now they have asked us to find the horizontal force, that is P, with which the block will be just raised. They have given the value of coefficient of friction to be 0.3, that is mu. Now consider the free body diagram of the body. The body will now have a motion in two directions, that is the motion towards the top of the wedge as the wedge begins to slide, and also an upward motion due to the sliding of the body with this contact surface. Hence, here there will be two frictional and two normal reactions acting on the body. Hence, we can find it out in the free body diagram that a frictional force of 0.3 R1 will act in the direction opposite to the upward movement of the body, and also there will be a normal reaction R1 which is set up. Similarly, there will be a frictional force 0.3 R2 that will act on the upward sliding moment of the body along the wedge, and also a normal reaction R2 which counters the weight of the 10 kilonewtons. Now, as there are more than one motion in a wedge and a body problem, here the components of the force are taken with respect to the horizontal surfaces, unlike the inclination surfaces where it was taken with respect to the inclined plane. So now here, resolving the forces in this circle, we have first 0.3 R2 which can be resolved as 0.3 R2 cos 20 and 0.3 R2 sin 20. Similarly, we have the force R2 which can be resolved as R2 cos 20 and R2 sin 20. Hence, we know that summation V is equal to 0 for the equilibrium. Hence, minus 10 minus 0.3 R1 plus R2 cos 20 minus 0.3 R2 sin 20 is equal to 0. Hence, we have minus 0.3 R1 plus 0.84 R2 is equal to 10. Let this equation be 1. Now, we also know that summation H is also equal to 0. Hence, R1 minus R2 sin 20 minus 0.3 R2 cos 20 is equal to 0. Hence, R1 minus 0.6 R2 will be equal to 0. This can be written as R1 is equal to 0.62 R2. Name this equation as 2. Hence, substituting 2 in 1, we have minus 0.3 R1 that is 0.62 R2 plus 0.84 R2 is equal to 10. From this, we have 0.654 R2 is equal to 10. Hence, R2 will be equal to 15.29 kilonewtons. Now, consider the free body diagram of the wedge. Well, the wedge will also have a friction as it moves along the horizontal due to the applied force P. Hence, there will be a frictional force of mu r that is 0.3 R2 set up in the direction opposite to its motion. Also, a normal reaction R3 will also be set up. Similarly, due to its motion along the inclined plane, there will be a frictional force opposite to that of the motion 0.3 R2, and also a reaction force due to the contact with the body, that is R2, will act at an angle of 20 degrees to the vertical axis. Hence, now resolving the components in the circular area, we have the components for the force R2 to be R2 sin 20 and R2 cos 20, and for 0.3 R2 to be 0.3 R2 sin 20, 0.3 R2 cos 20. Now, summation V is equal to 0. Hence, R3 minus R2 cos 20 plus 0.3 R2 sin 20 is equal to 0. Hence, we get R3 minus R2 that is 15.29 into cos 20 minus 0.3 sin 20 is equal to 0. where R2 is taken as common. Next, R3 will be 12.8 kilonewtons upon solving this. Now, summation H is also equal to 0. Hence, we have minus P plus 0.3 R2 plus 0.3 R2 cos 20 plus R2 sin 20 is equal to 0. Minus P plus 0.3 into R3, that is 12.8, plus taking out R2 common, that is 15.29, into 0.3 cos 20 plus sin 20 is equal to 0. Hence, we have minus P plus 13.34 is equal to 0. Hence, from this, we get the value of the horizontal force P to be 13.34 kilonewtons. Thank you.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.